Hello everyone, welcome to Ops on Cloud. In this specific video, let's try to discuss about one more interview question. So what's the question? Describe an approach to automatically detect and replace bad pods that degrade performance but haven't fully failed yet. Interesting question. And this is a question which is asked frequently in multiple interviews. Many of my candidates have mentioned this question. Okay. So, and you can expect this question if you are applying for job roles, which is more than 5 years. Okay. So you can consider this somewhere between intermediate to advanced question. And this is a problem which almost every engineer who is working with Kubernetes in any environment would have failed actually. Okay. So let's try to answer. So how do you answer in the interview? That's it. So basically, I would set up an advanced health checks or I will use external monitoring like Prometheus to track the response time and error rate. Okay. If a pod consistently exceeds these thresholds means you will have metrics like latency, error, all these metrics are there. Based on the metrics, you will define the threshold. All right. And then we use webhook or operators like for example Argo rollouts, which would initiate the rolling replacement of that specific pod. Okay, for added resiliency, we can implement circuit breakers at the service mesh layer. We can also make sure that the traffic is automatically routed away from the problematic pod until it's being replaced by the orchestrator. Okay, this makes sure that there is minimal impact on the users and helps us to maintain the overall system performance. Now let's try to understand this answer in detail. When you answer in the interview for this specific question, just answer this much. The in detail part, whatever I'm going to explain, that's only for your understanding in a real time way. That's it. All right. So first step, basically what happens is when you run your application in Kubernetes, right, you will have multiple pods or containers. Okay, so basically multiple pods means it's group of containers itself that will handle all the requests. And sometimes what happens is the pod will start behaving weirdly, I would say. Okay, so all of a sudden it will be running, it you'll see like it's running very slow. Okay, and also it will be giving some random errors. All these things will happen. Okay, but you'll also see that the pod has not completely crashed or failed. Okay, in the standard health checks that we have configured. Okay, this situation is always tricky because there is no yes or no. Your pod is not yet dead. Okay, that's a problem. You can consider that as a bad pod. So why do we need to detect? Okay, if a pod is responding slowly or if it is giving us errors in between, right, it will definitely have negative impact on your users in production. Okay, so see if you are catching these issues very early, right, you can stop the cascading effect to other pods and you can also stop the widespread downtime also. Okay, so basically if a pod is stuck using too much memory or CPU, replacing it will always help the system to run more efficiently. Let's assume you are working for Amazon. Okay, and one of your pods starts like behaving slowly due to a memory leak and it hasn't crashed yet, but it's taking too much too much time to respond. So because of this, if the orders are started failing and the customers, if they start seeing delays, right, so there is a very high possibility that the customer support tickets, whatever is there, that might increase, and that will again add load on Amazon, right, which is an e-commerce company, right? So what do we do for this? So most of the teams use basic health checks for sure, like liveness, readiness probes in Kubernetes that will only check if the container is up. However, the problem is these probes are there, right? They don't check if the pod is slow or partially failing. So that is where we need to create probe endpoint that will check metrics like response time or resource usage. For example, if it does not respond to a test request under 500 milliseconds or something, then you will get alerted. You can also run sidecar containers. Basically, sidecar containers is like an extra container which will run along with your main container, and that will get information or metrics so that we can analyze the CPU, memory, the request latency, all those things. And if the thresholds will exceed, right, the sidecar container, whatever is there, that will mark the pod as not ready. For example, instead of simply checking if the pod is alive or not, right, we can check if the pod is responding under 200 milliseconds on our home page endpoint. If that specific request is taking more than the expectation, then we can simply mark it as unhealthy pod. Okay. And also, one more approach is we need to use tools like Prometheus, Datadog, so that we can keep track of all these error rates, latencies, and the resource usages. Okay. So basically what we can do is we can configure a monitoring tool we can basically configure these monitoring tool, and we can create a webhook kind of thing. And whenever we detect the issue or any unusual behavior, right? So this webhook, whatever is there, we can simply tell the users or clusters or the deployment systems simply to replace the offending pod. Okay. And also, if we see the pods hitting high CPU or memory usage, right, consistently, so we can implement this horizontal pod autoscalers or cluster autoscalers so that we can simply, I mean, like, scale in and scale out. But the problem is blindly scaling and scale out with scaling out without fixing the issue is always not a good practice. Okay, that is one thing. And the other area is we can also basically think about implementing circuit breakers. So what is a circuit breakers? We have service mesh. You can use Istio or Linkerd for that. So basically, a circuit breaker means it will it will it checks for the pattern. Okay, and it will simply stops sending the traffic to the specific pod or a service when it's returning like too many errors or it's taking too much of time. For example, once you can configure a circuit breaker to trigger, I mean, like, and you can simply route the traffic away from the bad pods if you are getting like 5 out of 10 requests are failing within a specific 30 seconds of time. So like that, for example, I'll take an example. Okay, so let's assume you have a booking service and your pods will start giving 500 internal server error for some unknown reason. And now what circuit breaker will do is it will check. Okay, and it knows that more than 50% of the requests are getting failed in last 10 seconds. Okay, and now it will open the circuit, meaning it will not allow us to send the traffic to that specific pod. It will simply make it as bad pod. In the meantime, the orchestrator, which is like Kubernetes, what it will do is it will replace the bad pod with a good pod so that we can come back to the business again. Okay, so this is how we do it. All right. So simply, like, I hope you understood the concept of implementing this. All right. If you need any specific hands-on, I mean, like, kind of a video for this, please let me know in comment section. We will try to create a video explaining this specific concept itself. All right. I hope it helps. And when you answer in the interviews, just make sure that you will not give so much of answers for this. It's not really necessary. You just focus on this part, whatever I have written here. All right. If the interviewer asks you to explain in detail, then you go ahead and explain the second part. Okay, just try to take an example of a microservice that you have seen in your project and build a story on top of that. Okay, that's how you are supposed to use answer. I hope this really helped you a lot. Thanks a lot, and please make sure that you like and subscribe to your video, sorry, my video. uh, See you. Bye bye.